Lesson 3.1 will start out with perfect squares and square roots. I just kind of want to show you guys the difference right here. On 2, we could immediately, I know in your head, you could immediately tell me that this answer is 2. Now, look at number 1 though. This is saying x squared equals 4, meaning we have to solve for x. So in order to get rid of this square root, to get rid of this squared, we would take the square root. And remember, what we do to one side, we must do to the other. So taking the square root of a square cancels both of those out and just leaves me with what is up under, or what is being squared. So now I have x equals the square root of 4. Okay? Here it is a little bit different. Although it looks the same, this is whenever I will have 2 possible answers. My answers are going to be x is going to be 2 and x is going to be negative 2. Now let me explain that difference. What that means is, guys, is whenever I have, once again, this equation, x squared equals 4, I can take either of these values of x as 2 or negative 2. If I take 2 and square it, that gives me 4. If I take negative 2 and square it, that's negative 2 times negative 2, which is negative is a positive, which equals 4. So basically, guys, when we have an equation that a variable is squared and equals a perfect square, it's going to be 2 possible answers. Only on the squared, though. So on number 3, I have x squared. I got to get rid of that square root. Got to get rid of the square, on the terminology. Take the square root, that cancels out, leaving me with just x. What I do to one side, I do to the other. Square root of 81. This x is going to be positive 9 and negative 9. Because once again, when you put negative 9 into x, negative 9 times negative 9 is positive 81. But here, guys, this is just taking the square root of 81. That is just a simple 9, not a negative. On to 5, because we have equation y squared, this is going to be 2 possible answers. Now, guys, I know you guys will be using different calculators, so it just depends on which. I can't do a calculator tutorial because there's too many different calculators that we're probably using. So if you do not know how to take the square root or cube root in your calculator, you just YouTube the type of calculator you have and say, how do I take the cube root in this calculator? So I would take the square root of 625 and find out what that is. And it is 25. And y, because it's an equation, y will equal positive, this is a sign for positive or negative, plus or minus 25. So it has 2 answers. Now 6 is a little bit different. When you're taking the square root, trying to get a by itself, so we take the square root, cancels out. What we do to one side, we do to the other. When you take the square root of a fraction, it's very simple. It's just you take the square root of the numerator, which is 8, and then you're going to take the square root of the denominator, which is 9. The only difference is it is an equation, so it's going to be positive 8/9 and negative 8/9. So that's basically 3.1. That's just going over the perfect squares and square roots. Now going on to the perfect cubes and cube roots, this is going to be a little bit different for the fact that even on an equation, you're still only going to have one answer. So you take the cube root here, it cancels out, cube root. So really you're left with x equals the cube root of 8. Well, the cube root of 8 is 2. And how I know that, that's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay? So there is only one possible answer here. It's not going to be a negative for this reason right here. If I did negative 2 times negative 2 times negative 2, that would be negative times a negative is a positive, that's 4, times another negative, that would be negative 8, which is not what we have. So on cube roots, you will only always have one answer. Cube root of 8 is, cube root of 8 is 2. See how those will be the same here, even with an equation. On to number 3. Once again, take the cube root. Take the cube root. Okay, so back to squares real quick. You are not able to have that's an imaginary number. That is not possible because there's not one number you can multiply by itself and still get a negative. Okay, but on cube root, because you're multiplying something out 3 times, you can have a negative up under the cube root. The answer to this, a cube root of just positive 27 would be a 3. But the cube root of negative 27 is going to be negative 3. One you can do in a calculator, but let me show you how that works. So all that is negative 3 times negative 3 times negative 3. These first two, negative 3 times negative 3 is a positive 9. Negative times negative is positive. Bring down this other one we've not multiplied with. Negative 3 times positive 9 is a negative 27. Okay, but your calculator does do this for you. And once again, you will see that this is the same. This will be a negative 3. So on perfect cubes, the equation and the problem is no different. They all only have one answer. Same thing on 5. Take the cube root, y equals negative, let me make sure of this, I just typed it in the calculator. Okay. On 6, the cube root of a fraction will be the same. You take the cube root, this cancels out. You just bring down the w. Take the cube root of the numerator, which will be 2, and the denominator, which will be 7. There will only be one answer. Same thing as 7. Cube root cancels out. Cube root, bring down my y. Y equals the cube root of 1 is just 1. And the cube root of 1,000 is 10. It will not be a positive or negative. It's just, on cube roots, it's just one. It could be either positive or negative, but it's only one solution. So that wraps up 3-2. That's just a simple basics. Now we're going to use these exponents. We're going to put these exponents into play. Alright, I'm going to show you first off. This would be great for you to just, even if you recopied all these notes, that would be great. These are the types of things we're going to learn. Multiply powers with the same base. When you multiply powers with the same base, what the base is this big number. Your whole number is your base. Or it might be a variable. Okay, so when you're multiplying with this same base, you're going to add the exponents. So 2 plus 3 will be added together. Once again, x is your base here. When you multiply with the same base, you have x and x. You're going to add to, you got 3 bases here. X, you're going to add 3 plus 5 plus 10, which will give you x to the 18th. Multiplying with the same base. Your same base is m. The only difference here is you're going to pull out that 2 and the 5, multiply that, keep your base, and add your exponents. The next one is power to a power. That's basically when 2 numbers are side by side, we know we multiply. So power, this 2, is raised to another power. You multiply the 2 exponents. So 5 to the second times 3 is 5 to the 6. You keep your base. 3 times 4, x to the 12. You keep your base. Power to a power, 5 times 6, a equals 30. Power of a product, whenever you have a product that's a multiplication and it's being raised to a power, raise each factor inside of here to that power. So here we have a product. You're going to raise the 2. It's just like distributing. 2 will be raised to the third and 3 will be raised to the third. And then you just simplify. Here, 3 will be raised to the second, C will be raised to the second, and D will be raised to the second. Everything inside. Here, 5 will be raised to the third. M squared will be raised to the third. N cubed will be raised to the third. But you will go on to have a power to power. You have to multiply. Dividing powers with the same base. When you see this dividing bar, think of subtracting. Think of that dividing bar as subtracting. So here, when you're dividing with the same base, you're going to subtract 6 minus 2. Dividing 13 minus 9, you subtract the exponents in division. Power of a quotient, you're just raising both numerator and denominator to that power. This is huge. Huge, huge, huge. Anything raised to the 0 power is 1. Listen to me carefully. So many kids get this mixed up. They want to say, oh, it's raised to the 0 power, answer is 0. No, no, no. If something is raised to the 0 power, the entire problem, everything but just becomes 1. It's not 4 to the first. Everything just becomes 1. Negative exponents. Alright, this is how I teach this. When we have a negative attitude at home with our parents, we get in trouble. If we're negative, if we're smart mouth, we get in trouble. And when we get in trouble, we usually get grounded or sent. Well, when kids we sat in timeout, usually get grounded, get sent to your room. Well, I think of it, if you're negative, you get sent to the basement. And what the basement is, this is the upstairs. Up top's the upstairs, downstairs the basement. So when you're negative, you've got to go to the basement. So the 1 comes on top, you go to the basement, 8 to the 5th. But when you're down at the basement, that negative attitude, it changes into a positive attitude. So you get in trouble, you go to the basement, and then you have a positive attitude, which is a positive exponent. Once again, x to the third, you're negative. You go to the basement, you have a good attitude, you turn into positive. So those are some notes you can copy down. Let's go on to do some examples. So here I have same base being multiplied. When the same base is being multiplied, you keep that base and you add the exponents. So what that is, that answer will be 5 to the 10th power. And we have simplified now. Going on to number 2. Same base. X is our base. We're multiplying the base. So you'll keep one base and you will add these exponents. This one's a little bit different. You have a 2 and a 5 out. Our best thing to do is to pull out our constants. Pull them out. Because this is multiplication, you will be multiplying your constants. Pull the constants out, and now you have the same base. Now you have the same base, and it's being multiplied, so you will add the constants. So here, simplify. 2 times 5 is 10. M to the 10th plus 2 is M to the 12th. That's your answer. Once again here, you have the same base of y, but you have 2 constants. Pull those constants out. 3, there's multiplication going on, so you're multiplying it. Y to the 4th plus 7. So this is 15 y to the 11th. Alright, does x to the 8 times x squared have the same value as x to the 5th times x to the 5th? Well, we need to simplify these. X to the 8 times x squared, you're multiplying with the same base, so you add the exponents. 8 plus 2. That equals x to the 10th. Now here, you're multiplying with the same base as x, you add the exponents. 5 plus 5 is 10. Does these two have the same exact value? And yes, they do. It's 10 to the 10th. A few more examples of 3.3. Power to a power now. Power raised to a power. That's when you're going to multiply. Think they're side by side. When we have 3 times 2, we know we're multiplying. So side by side, we're multiplying. Keep the base. 10, you're only multiplying the exponents. 3 to the second, 3 times 2 equals 10 to the 6th. Your base is x. Power is raised to a power. Multiplication side by side. 3 times 4, x to the 12th. Our base is a, power to a power. 5 times 6, a to the 30th. Our base is g, power to a power. 9 times 6 is 54, g to the 54th power. Okay, this is where it's a little more of a difficult. We have a product going on here. We have 3 things being multiplied. So we need to separate those. I think 3 times c times d squared. Every single thing inside of here will be squared. So this 3 will be squared, c will be squared, and d will be squared. This simplifies to 9, c squared, d squared. So you can write it like that, or just 9, c squared, d squared. So just if you have more than one thing in the parentheses, it will all be raised to the power on the outside. So that covers 3.3. Moving on to 3.4. Remember this bar. Think of this bar division. You will subtract the exponents. So this is 8 to the 10th minus 7. Our base is 8. You subtract 7 from 10, which is 8 to the 3rd power. Same base as y. Division, so you subtract 13 minus 9. This will be y to the 4th power. Same base, d, being divided, so that will be subtraction, 20 minus 13. This will be d to the 7th power. 4. Same base, g. 35 division, so we'll subtract 35 minus 23 with g to the 12th power. Does a12 to the a8 have the same value as a6 divided by a second? Well, let's simplify. Same base as a, so we'll do division, subtraction, 12 minus 8. And that will simplify to a to the 4th. Now a to the 6th, our base is a. We'll subtract 6 minus 2. And that is also a to the 4th. So yes, these do have the same values. Go on to 3.5. This is 0 and negative exponents. Alright, right here on this one, it's just simple. If you can see, it's everything on the top, the same thing as on the bottom. We know when the top's divided by the bottom, or vice versa, the answer is always 1. Okay? I'm going to tell you another way that, this is another way they solve. 18 divided by 18, we know that's 1. So if you have x to the 20 over x to the 20, you have the same base of x. You subtract the exponents, 20 minus 20. That's x to the 0 power. And we know anything to the 0 power is always 1. Here, w to the 8 over w to the 8, that cancels out and just leaves you 1. Now z to the 15th over z to the 8, that's division, so you will subtract 8 from 15. The answer here is 7 to the 7th power. On the 3, you have these two constants. Go ahead and simplify that first. 9 divided by 3 is 3. Now you have x to the 5th and x to the 2nd. Your base is x. You're subtracting. That's going to be 5 minus 2. Okay? We'll simplify below. Now we have, well, y to the 2nd. Y to the 12th or y to the 12th. Once again, that just cancels out. That's 1. So here we have 3 to the x to the 3rd power. 5 minus 2 is 3. This is our final answer. Okay, so here I have 5. This is like being 5 is being multiplied to x to the 0 power. Well, we know anything to the 0 power, that whole thing turns into 1. But that 1 is still being multiplied to 5. So your answer here is 5. Now, if that 5 was not here, if it's just x is 0, the answer would just be 1. For instance, here, this is a number. Even though it's a decimal raised to 0. The answer is 1. Anything raised to the 0 power is 1. Now, here, you have division sign. So we know we're going to subtract. 2 is our base. So we have 8 minus 11. But 8 minus 11 is 2. 8 minus 11 is negative 3. We cannot have a negative exponent. If you're negative, you go to the basement. So that you're going to have a 1 as the numerator, and that 2 to the negative 3rd will go to the basement, and when you're at the basement, you become positive. There are a few more examples of that. Alright, so you'll simplify this first. 100 divided by 200. That's going to be, just cancel those zeros out here. It's going to be 1/2. Okay. Now, b to the 50th. Our base is b. We're dividing, so we'll subtract b to the 50 minus 75. So you have 1/2 b to the negative 25. Well, it's just like this 1 is with, this is on the same top as the numerator, but it's negative, so we know it's got to go down to the basement. So the answer will be 1/2 b to the 25th power. When it goes to the basement, the power becomes positive. Now, once again, this is where it gets a little bit difficult. Let's just do step by step though. So we know we're going to be subtracting all these exponents because it is division going on. So I have a to the negative 3 minus 5. Now I have b to the 7th minus 2 and c to the 5th minus 7. So this negative times negative sign's the same. Keep the sign, add the numbers. You can put in your calculator as well. Now, b, 7 minus 2 is just 5. C, 5 minus 7 is a negative 2. We would be done except we have some negative exponents, and we cannot have negative exponents. So what you do, you keep what your numerator would be, which is the positive exponent. This will stay at the top because it's positive. And then the a to the 8th will just go to the bottom and become, that negative 8 will become positive 8. And c to the negative 2 will be positive 2 because it goes to the basement. You take it below b to the 5th and it becomes positive. Alright, this is where we have everything going on in here is being raised to a power. So everything inside of this has to be raised to the negative 2 power, including the constant. So I have 2 to the negative second, x to the third to the negative second, y to the negative fifth, raised to the negative second. So here we have power to a power. Well, only 2. This is just 2 raised to the negative second power. We'll leave that as that at the time, and we'll come back to it. Power to a power is going to be multiplication. So this is x to the third times negative 2. So, and same as here, that would be y to the negative fifth times negative 2. So just be careful on these sides. X, positive times negative is going to be negative. 3 times 2 is 6. 2 negatives will be positive. 5 times 2 is 10. Okay, here now, coming back to this, you cannot have a negative exponent. Remember that. So, this is understood to be 1 under the bottom. All of this will come down to the bottom, and so it will be, 1 will be at the top, 2 to the negative second will come to the bottom and will become positive. So this will simplify to 1, 2 squared is 4. So your answer is 1/4. Well, we still have another negative, excuse me. I have to have more room. X to negative 6 is not simplified yet. This is a more difficult one. Okay. So you have a negative exponent again. So you have 1/4. The positive exponent is going to go at the top, which is y to the 10th. And the negative exponent is going to go to the bottom. But when it goes down to that bottom, it becomes positive. This is the final answer. Moving on to number 10. M. Same base, division, subtract the exponent. 2 minus 5. N. Same base, division, subtract the exponent. 2 minus 5 is going to be negative 3. N. 4 minus 3 is just 1. Okay, so n to the first power, that's just strictly n. But I have a number raised to a negative power, so it's going to go to the basement. It'll go down to the basement and become positive. It's 4 to the negative third power, greater than 1, equal to 1, or less than 1. We got to simplify first. 4 to the negative 3 is understood to be over 1. But we know we cannot have a negative exponent. So when we send it to the basement, it will then become positive. And technically we don't even have to simplify that, because we don't have to simplify it for the simple fact that we know it's a fraction, and a fraction, positive fraction, is going to be less than 1. But let's simplify it. A fraction, once again, is going to be less than 1. So that rounds up less than 3/1 to 3/5.